All right, somebody asked me about question 9 from our review, but they only asked about part C. I'm going to do the whole problem because maybe something that we do in part A and B will be important for part C. So anyway, we're looking at a function. We're looking at this wonderful function, the natural log cubed, but we're only looking at between 0 and 4. All right, so what are we doing? We're going to find a point of inflection. So I got to do a second derivative. So first derivative is going to be 3 times the inside squared, and then chain rule says you multiply by the derivative of the inside. That's the first derivative, but the question asked me about points of inflection. So point of inflection means I got to do that one more time. So I'm going to do f and g. We're going to do the product rule. So f prime, 6 natural log of x to the first times the derivative of the inside function times g. So this is f prime, this is g, plus f times g prime. Well, just remember that 1 over x is x to the negative 1, and you'll see that g prime is negative 1x to the negative 2. Great. Points of inflection mean we make all that equal to 0, and then we look for things that are in common. So what I see, by the way, this was my f times g prime, just to finish writing out my product rule. What I notice is that both terms have a 3, have a natural log of x, and have a 1 over x squared in them. The first term, if I pull all that out, is just left over with a 2. Check it for yourself that the 3 times 2 makes the 6, and then I have a natural log of x, and I have a 1 over x squared, taking care of both of those 1 over x terms. The second term is left over with a natural log of x and a negative 1 from g prime. So I could have written it as 2 minus natural log of x, but I just was going in the order I had written it before. So then we try to figure out, it's factored now, we try to figure out what the values of x are that make it equal 0. So 3 can't equal 0, we don't need to worry about that. Natural log of x can equal 0. Natural log of x equals 0 if x equals e to the 0. In other words, if x equals 1. So let's save that. 1 over x can't equal 0. Get rid of you. And then the other one is 2 minus natural log of x is equal to 0. 2 equals natural log of x. X is equal to e squared. So we have 2 different points that could be points of inflection. So that's the tricky thing, is that what we know is that the concavity is 0 there, but we don't know if it is truly a point of inflection or if it just pauses and then continues with the previous concavity, like going from concave up to then more concave up. Kind of like how when your first derivative is equal to 0, it can be increasing, flat, and then more increasing. Okay, so let's look at what the second derivative is on either side of those values. So one way to do this is it's kind of like when you're doing the first derivative test. One way to do this is to set up a number line. Here's x equals 1. Here's e squared, which is bigger than 1. And let's choose numbers that are on either side of it. So I'll just come up with test values. I'll use 0.5. Here I'll use 2. And here I'll use... Oh, actually, you know what? Lucky for us, e squared is already outside of our domain. That's good. Okay. So 0 to 4. If you think about e is a little bit bigger than 2, so e squared is like outside of our domain. There's nothing wrong with it mathematically, but we don't even need to worry about it anymore because we were told only to look at between 0 and 4, and e squared's outside of that. So this is our point of inflection's x value. To find the y value, we go back up to f of x. So f of 1 is the natural log of 1 cubed, which is 0 to the third power. So f of 1 equals 0. So that's our inflection point, 1, 0. All right, so now we want to find the tangent and normal to the curve at the point x is equal to e. And that doesn't have anything to do with our inflection point, and neither does part C. Okay, so let's go back. Let's create a little space here. So I don't need my second derivative anymore. I just need my first derivative because now the question's asking about tangent and normal lines at the point x is equal to e. So let's look at that. So when x is equal to e, what I'll need to know is what happens when I plug in e to the original function, natural log of e cubed. So that's going to be 1 to the third power is 1. So I know I've got e comma 1 as the coordinates on my original function. I'm also going to look at what the derivative, oops, lost that, that's okay. So my original function, natural log of x cubed, my derivative, 3 natural log of x squared times 1 over x. We know that f of e equals 1, e comma 1. Let's look at what f prime of e is. 3 times natural log of e squared times 1 over e. So f prime of e equals 3 over e. That's going to be my slope of my tangent line. So I'm going to call it mt. So that means that my tangent line can be written using your best friend point slope form. Y minus 1 equals 3 over e times x minus e. Remember point slope form. Point slope form is wonderful. You don't need to find a y-intercept. You just copy and paste the x and y values in and the slope. So that's the tangent point there, or tangent line there. And so then the normal slope, or the normal line, excuse me, is going to be y minus 1. And then you do the opposite reciprocal. So you just flip it over like that. Beautiful. Now part C asks, calculate the area of the triangle formed by this normal and tangent lines and the y-axis. Great. Let's draw a little picture. So y-axis here, we've got the point e comma 1, which is going to be kind of like this. We've got a positive slope. 3 over e is not a big slope. It's like about a slope of 1. So I'm just kind of doing this to visualize about a 45-degree angle here. And then same idea, negative e over 3 is going to be kind of close to that. So we want to find the area of this triangle. When I look at this triangle here, I can think of finding the area. You can define it a lot of different ways, but one way to find the area is to call this part the base and call this part the height. One nice reason for doing that is the base you can find by the two y-intercepts, and the height you already know because that's the point, e comma 1, meaning the height of the triangle is just e. So the last thing I want to do then is find the y-intercepts of my two lines. I'll do that by plugging in x equals 0 to each of my lines because that'll tell me the y-intercept. So on this one, one sec. Okay, so plugging in x equals 0 gives me y minus 1 equals 3 over e, 0 minus e. So we get y minus 1. The e can cancel here to give me negative 3. So y equals negative 2 if I add 1. And so that gives me this value right here at the bottom of negative 2. Same sort of idea on the normal line, y minus 1, negative e over 3, 0 minus, oops, I wrote the normal line wrong. This should be an e right here. 0 minus e. So then we get y minus 1 equals positive e squared over 3, which I guess y equals e squared over 3 plus 1. Not a super nice answer, but that's what it is. So then the area of the full triangle, right, is 1/2 base times height. So we're going to subtract those two y values because that'll give me the height of the base. I will multiply by the height, e. So we got 1/2 e squared over 3 plus 3, because that's a difference. If I take the e squared over 3 plus 1 and I subtract -2, and then I multiply that by e again. So that's the exact value of the area. If you want to get if you really care about the decimal value, type it into your calculator, see what pops out. So anyway, thanks for asking that question. Let me know if you got any questions or comments.